Number 2, a professional basketball player typically has their peak scoring average in points per game around the age 27 years old. So at 27 years old, they peak. Then afterwards, their expected scoring average typically begins to decline each season until retirement. The function below is used to predict the scoring average for a particular player X seasons after the player turns 27 years old. What is the best interpretation of the value 0.09 in the function above? So I'm just going to rewrite it over here. The function of x equals 21 times 0.89x. Okay, so what this is saying is the number of years after, I'll just write it, the number of years so the number of years after 27 and their expected, I'll put in quotations, expected scoring average until retirement. That's what our function's telling us. So what is this 0.89? So this is going to be a decay, an exponential decay. I haven't even looked at the, what do you call it, the formula yet, or the answers, but this is an exponential decay formula. So an exponential decay formula looks like so. F of x is equal to a, that's the first value, times 1 minus the rate to the power of x. So a, this is the starting point. And since this is decay, the r is the rate of decay. So this is kind of tricky because what they're saying is, what does this 0.89 mean? Well, first off, 0.89 is close to 1. So 0.89 is, if you do the math for it, it's not going to really affect it too much. So we got some distractors in here. The player scoring average is predicted to climb by about 0.89 points per game each season after the age of 21. That is not true because this functions after 27. So this is not true. Because its age is not, that's 21 points, not 27. The player scoring average is predicted to decline by about 0.89 points per game each season after the age of 27. This could be true. Let's put a star. The player scoring average is predicted to decline by about 11% each season after the age of 27. That could be true. The player scoring average is predicted to decline by about 89% each season after the age of 27. That's another one that could be true. So since we're looking at this through a lens of decline, I'm going to have to say, in order to get this formula, it's not going to be 0.89. So if we did 0.89 and we plugged it in and we equaled it to this formula, we get 1 minus r. So to figure it out, we're going to subtract 1 So you get 0.89 minus 1 equals negative r. So if we were to do a little simple subtraction, 1.00, 0.89, subtracted 0, 9, 10, 1, 1, put a decimal, we get negative 0.11 equals negative r, divide both sides by negative 1. You get r is equal to 0.11. That is our rate. It's not 0.89. Our rate is actually 0.11. So based off this right here, if we want to put this as a percent, because that's what it's in, that would be 11%. If we moved it over 2 decimal places like you do, 2 times by 100. So it's not declining by 0.89. The rate that it's declining at is by about 11%. So the answer here would have to be C. So the secret was we equaled it out, the value in the formula, to 1 minus r to figure out the actual rate.